In this video, I'll walk you through how to build a model using the model editor in TopLogic. But before we design the model itself, we first have to know what are the requirements. What do we need in order to fulfill those requirements? So for this example, we'll use the following context. We have a business, and a part of that business is the purchasing. So we have customers, they create orders, and in these orders, they will buy certain products. And this is a very simple requirement that we can model in here. So the first step we need to do is to create a new module within our application. So I'm going to call it first.app.purchasing and give it the name purchasing. The rest I'm going to leave as default, as I'm not really interested in a German translation for this application or a description in that case. But you're always free to configure each module, class, enumeration, attribute, etc. how you see fit. So I just created it, and it automatically organized it in my tree structure in here. If I go to the diagram, I can now see the visualization of our model, of the module using UML. So coming back to our context, we need three entities. We need the customer, the order, and the product. So I'm quickly gonna drag and drop here and create those classes. So the customer, we're gonna create the order, and we're gonna create the product. Now that we have our entities, we can start by creating the attributes. So let's start with the customer. So a customer usually has like a name, email, phone number, and other specific attributes. And these are attributes that will be coming more often in the application. You know, we have a lot of different persons, not only customers, but maybe also suppliers, etc. So one thing we can do is we can use the functions or the modules that TopLogic already provides. And TopLogic provides one class or one entity called person. And this person, if we look for it here, we can search person. We can see we have two types of persons. One is a user account, so this person will usually have access to our application, and the other one is just a person without user access. And this is exactly what I would need in this case. So if I go back to a diagram, to the purchasing diagram, go over here, and I can then drag and drop this person entity into my module purchasing. And now I can click on the customer and create a new inheritance connection. So in that case, a customer will be a person. And in that case also, if we go to the attributes, we cannot see any attributes in here now because we haven't defined class or this customer specific attributes. But if we click on the context menu and click show attributes of supertypes, we can see we now have all those attributes inherited from the person class. And these already include many of the attributes we want to define for our customer. However, for our context, we have another requirement, and that is our business has active and inactive customers. So I'm going to create a new property called active, which is going to be a boolean, and I'm going to call it active, and this will then later show us whether the user or whether the customer is active or not. And this logic of whether the customer is active or not, we can later specify more clear, but first we'll start with other attributes. If we go back to our diagram, we can click the refresh button here to reorganize the UML so it's more readable. So next up would be to define the attributes of the product. We can do that in here as well. We don't need to go to the attributes tab. We can just click here and create attributes. So a product is going to have a name, which is going to be a string and mandatory. Another attribute is going to be the description of the product. It's going to be a string as well, but this is not going to be mandatory in my case. So I'm going to leave the rest here as default. Then I'm going to create another attribute, and this is going to be the price of our product. And in my case, it's going to be a double. And it's also going to be mandatory. Another useful property of a product maybe would be the quantity that we have for our business for that product. So I'm going to create a property called quantity, and it's going to be an integer, and this is going to be mandatory as well. Great, now we have the product with its specific attributes, we have the person with the attributes, and now we have the order. And an order usually has a specific status the order is in, whether it is being processed or whether it is fulfilled, rejected, or finished. And this is a perfect use case for an enumeration. So I'm going to drag and drop this enumeration here, and I'm going to call it order status. Great. And here I'm going to go to properties and then add some classifiers that we can then select. So what I said is we have a classifier called processing. So our order is still processing. We have one called delivered. So, and then maybe one returned. We can have more, but I'm going to keep it simple. Great, if you go back to our diagram, we have the enumeration and the order. And I'm going to say, I'm going to create a new association. So I'm going to say one order has one order status, and I'm going to call it status. And this will be mandatory as well. Great. So now we can see in the UML diagram that one order has one status, and the enumeration order status can be for as many orders as it wants. So we have the association to the status, and now we need the association from order to product and customer, because one order is always belonging to one customer. It's mandatory as well, and one order is always related. Oops, I did the wrong one. One order is always associated with one product, and it's mandatory as well. And for this sake, I'm gonna leave out multiple values, but usually orders can be for multiple products. But to keep it simple, I'm just gonna say one order is always belong to one customer and one product. I'm gonna click the refresh button, and our model already looks nearly complete. So the rest of the attributes I'm just gonna define in here. So we have a number, so a unique identifier for our orders. So it's going to be a string in my case. And yeah, that's one. Then an order is going to have a date. So I'm going to use the type date as well and make it mandatory. An order also going to have the quantity. So I'm going to call it quantity, which is going to be an integer. It's mandatory as well. And an order should have a value to see, okay, how much is the order actually worth. I'm gonna keep it as a double. Great, now we have our model set up, and we could start by creating instances or later on also views for this specific module. But what I want to do is I want to show you the customizations that we can do now. And I'm going to start with the customer, specifically the attribute active. So one of the requirements from our context is that a customer can either be active or inactive. And that can depend on certain conditions, let's say. And what we don't want in our application is that the administrator goes through every customer and says, okay, this one is active, and then checks the conditions, and then this one is active or not and checks his conditions. We want the system to do that for us. So we want to automate that part. And this we can do very easy in here. If we go to the properties and add a customization, we can say storage algorithm. And this annotation is choosing as a custom storage implementation for the attribute active. So if I click here, we have the possibility to define a function. And in here we can input tail script. If we hover over this function, we can then see information about how to use the specific function. And in here, it says the expression is expected to be a function that takes the context object that declares the attribute as a single argument. And in our case, the parameter we have here available is the customer. So I'm going to write customer and then create the base of our function. But before I write it, I want to explain how customers are going to be ruled active or inactive. And for our use case, I'm going to keep it simple again. I'm going to say a customer is active when the customer has at least one order. So in order to do that, we need to access the orders of the customer. But if we look back again at our model that we created in here, we can see we have an association from order to customer, but we didn't define the back reference from customer to order. So this one is missing. So before I continue with this function, I go back to the model and click on the association. And here I have the possibility, if I go on the context menu, to say new backwards reference, and I'm going to say this is the order. So now if I go to the customer and go to its attributes, I can see, let's filter out the super attributes of the super type. I can see I now have a new attribute called order, which allows me to get access to the orders of that customer. Back to our diagram and to our attribute active. Now let's add the customization that we need. So I'm going to go here and then go to storage algorithm and then create the function. So the first one is we want to get the orders of the customer. So this will be orders. We're going to create a variable called orders, and we're going to say from the customer, we refer to the variable customer by using $. So from the customer, we want to get the order attribute, and we can get the order attribute by referencing its full technical name, and its technical name is defined in here. In this case, it's the technical name of active, but we can just copy this one and then create some two backticks and enter it in our backticks. And we can access any attributes now of customer by clicking hashtag, and then we can select order. Great. Now we have the orders of our customer. Now, in order to return true, orders cannot be empty. And this is what we're going to do here. Return true if orders is not empty. So we need to access orders. And now we can use some functions that already come with TopLogic. Yeah, that you probably know from Java, Python, etc. These are functions that are useful to have. And one of them is called isEmpty. And if empty checks if the set that we give here, orders, is empty, an empty set, or is null. And that is exactly what we need. So I'm going to call it here and say, I want to return this value. But this would return true if it's empty. And we want to return true if the orders is not empty. So before we do that, we just give back the opposite of orders is empty. Now we save it, and we created our storage implementation for the active boolean, which now says a customer is active if he has an order, and if not, he's not active. Another attribute we want to customize is the number, because we specified the number will be the unique number for each order. So each order has only one unique number. And to do that, we also have customizations. So we go back here, we click on customization, and in that case, we want to give it a default value. So basically a value that it will always take, and that will be a sequence. So we search here and then look for anything that we can use, and in that case it is here, default value. And now on the provider, we don't want to give it a constant value, we want to choose something else. And in our case, we said we want to have a ID. So here we now have to configure some more options. Yeah, we have to give it sequence name. In my case, it's going to be the order number, and the pattern of how the sequence is gonna be rendered. And in here, if you hover over the tooltip, we can see we're gonna have access to the number, access to an object, and access to date. And these are defined using the number here, the number format, the date format, and then here as well the object later on. But this is a bit more complex, and for simplicity, I'm gonna just say our ID will be the date minus the number. So in the number format, I can also specify how I want the numbers to be shown. If I just leave it with a hashtag, it's gonna format the number with as many digits as required without leading zeros, and that's not really what I want to do. I want to keep it unique and simple, so I'm gonna say 00 because I know from the context maybe that usually in a day there's not more than 100 orders, so for me this number format is sufficient. So for the date format, I'm going to use year. If we click here on the tooltip, you can see what you can select. So I'm going to see year, month, and day. And then in here, I can define the date, and I'm going to say I want to show the date, so the year plus month plus day minus the number. In that case, 0, 1 for the first one, for example. Great. Now we have that. And the last one we need maybe to automate is the value. Yeah, we can say, okay, we have an order is related to one product. The product has a price, and we defined a quantity of how many products we want to buy of that specific product. So we can go back here and go to customization and click the same storage algorithm, because we want to say, okay, from our order, we want to say get related product, get its price, and get our quantity, and then calculate the value. So we can do that. We can say product equals order.get, and then we're gonna choose the fully qualified name. So first.app.pushing.order hashtag product. Now we have the product related to the purchase. We can get the price of product, which is gonna be $product.get, because we're gonna access this this attribute from product. So I'm gonna say again now first.app.purchasing.product hashtag price. Now we get our quantity. So quantity equals order punct, oh sorry, I forgot, $order.get first app.purchasing order hashtag quantity. And now we just need to calculate the value. We can just give it back by saying please multiply the quantity times the price of the product. And make sure you also always use the $sign when referencing or trying to get a hold of the value of our variable. And there you have it. We just made our model, and it's now time to test it out by creating some instances and seeing how the values change depending on the setting of attribute values. So the first thing I'm going to do is create two products. So I'm going to click here on the product and then on instances, and then create two products. So product A, which has the price of 200, we have 500 in stock, and also product B, it has the price of 100 and we have 400 in stock. And then the next one is we define a customer. So we click the customer, we click instances, and then we say we have one customer named John Doe. Maybe the rest I'm going to leave it empty for now, and one Jane Doe. And what you can see here, the active boolean is already calculated. It looked at the order value of the specific customer and saw it is empty. So in that case, we just returned false. And then we can select the order in here as well, and then create our first order. Great. So our order, we have to select the status. So the first one is going to be processing now. We're going to select a customer, in that case, maybe John Doe. We're going to select a product. We're going to select product A. And number, we should leave empty in here because this will be automatically generated for us. And then the day, we choose maybe the today, and the quantity, we will say, okay, we want to have maybe like 100 from product A. And we can see it automatically got the price of the related product and multiplied it by the quantity, which gives us our value of this order. Great. And once we successfully created this instance, we can see that it also created our unique number. If I go back to the customer instances, we can now see there has been some changes as well. First of all, the active is now true as we have a customer with one order. And the order we can see in here. However, this now says unnamed object of type order, which is normal because we didn't define an identification attribute for the order entity. Usually it takes the attribute name, but as we haven't defined the attribute name in here, it doesn't know how to render, how to name any instances of our order. So in our case, we want our order to be identified by their number. So we can go to the Properties tab to customize the entity and then click TL ID column and then select number and save. So if we go back to our customer, to the instances, we can now see the order is correctly specified and shown to us. The next step would be to save the module that we just created. So we'll go back to the module and then go to the context menu and click transfer to IDE. Then if it's the first time you do that, a window will pop up warning you saying, okay, the file was just created, but you have to terminate all sessions before later on you commit or you transfer another information to the IDE. If we then see that one, the change in Eclipse, we can then see the changes that happened. So we got a configuration file, we got the model file where specifically for the purchasing module where we defined the classes, the attributes, etc. And then some translations that we specified individually or were created automatically by TopLogic. And yeah, that's it. if we go back to the module, we can see what we created, and we can also maybe already detect some changes we can make to further augment this model. But this is just the introduction on how to create classes, enumeration modules using the model editor. And maybe the next step would be something like creating a user interface for an administrator to um, create customers, to create products, and to create orders.